The following Venn diagram shows two events A and B, where the probability of A is 0.3, the probability of A intersection B is equal to 0.2, and the probability of A union B is equal to 0.7. The values of P, Q, and R and S are probabilities. Part A, write the value of R. Well, R is equal to the intersection, which is the probability of A intersection B, which is equal to 0.2. B part 1. Find the probability of P. P is equal to the probability of A minus the probability of A intersection B. So P equals 0.3 minus 0.2, so P equals 0.1. B part 2. Find the probability of Q. To find Q, we're going to use the fact that the probability of A union B is equal to the probability of A plus Q. Therefore, 0.7 is equal to 0.3 plus Q. Rearrange to find Q. Therefore, Q is equal to 0.7 minus 0.3. Therefore, Q is equal to 0.4. B part 3. Find the probability of S. We're going to use the fact that the probability of the whole union, all of it, is equal to the probability of A union B plus S. Therefore, 1 is equal to 0.7 plus S. Therefore, S is equal to 0.3. Part C. Find the probability of B. We're going to use the fact that the probability of B is equal to the probability of A intersection B plus Q. Therefore, the probability of B is equal to 0.2 plus 0.4. Therefore, the probability of B is equal to 0.6. Question 2. Two events A and B are independent. This fact that they're independent will be important later on. We're told that the probability of A intersection B is equal to the probability of A intersection not B, and that is equal to a probability of 0.3. First thing we need to do is draw a Venn diagram and put on the relevant information. Now let's put in our probabilities. So the intersection is equal to 0.3. We have to identify this section, the probability that A intersection not B. Well, this is this section here. So this also has a probability of 0.3. Part A, find the probability of A. Well, that's easy. The probability of A is the whole circle of A. So it is 0.3 plus 0.3, which is equal to 0.6. Part B, find the probability of B. To find the probability of B, we're going to use the fact that they are independent. And we have a formula for independence. We know that the probability of A intersection B is equal to the probability of A times the probability of B for independent events. Therefore, we have got 0.3 is equal to 0.6 times the probability of B. Therefore, the probability of B is equal to 0.3 divided by 0.6, which is equal to a half. B part 2. Find the probability of A union B. Well, the probability of A union B is the probabilities of the two circles. We know that the probability of B is 0.5. The intersection is 0.3. Therefore, this section must be 0.2. Therefore, the probability of A union B is equal to 0.3 plus 0.3 plus 0.2. So the probability of A union B is equal to 0.8. Question 3. Two events A and B are such that the probability of A is 0.58 and the probability of A intersection B is 0.6. Part A. Find the probability of A intersection not B. Well, the probability of A intersection not B is equal to the probability of A minus the probability of A intersection B. Therefore, the probability of A intersection not B is equal to 0.58 minus 0.16, which is equal to 0.42. Question 4. At a travel agency, 8% of employees speak both Spanish and Dutch. 60% of employees speak neither of the languages. The percentage of employees who could speak Spanish is twice the percentage of those who can speak Dutch. A. Find the probability that a randomly selected employee can speak Spanish. Well, we know from the information that's 40% can speak at least one language. Therefore, the probability of S union D is equal to 0.4. From the formula booklet, we know that the probability of S union D is equal to the probability of S plus the probability of D minus the probability of S intersection D. We're also told that twice as many people speak Spanish. So therefore, the probability of S is equal to 2 times the probability of D. Therefore, we know that the probability of S union D is equal to 2 times the probability of D plus the probability of D minus the probability of S intersection D. Plugging in our numbers, we get that 0.4 is equal to 3 times the probability of D minus 0.08. Therefore, when we've rearranged it, we get that the probability of Dutch is equal to 0.16. Therefore, the probability of S is 2 times 0.16, which is equal to 0.32. Part B. Given that a randomly selected employee can speak at least one of the languages, find the probability that they speak Spanish. This is conditional probability. We have reduced the size of our sample space to only those that can speak at least one language. So the probability of people that can speak at least one language is the probability of S union D, which is equal to 0.4. And we have got the probability that they speak Spanish is 0.32. So the probability that they speak Spanish, given that they speak at least one language, is equal to 0.32 out of 0.4, which is equal to 0.8. Question 4 is about normally distribution. The random variable x is normally distributed with a mean of 90, which we can put in. That's a mean of 90. The following diagram shows the normal curve for x. Let R be the shaded region under the curve. So that's the whole region under the curve. To the left of 84, the area is 0.22. So let's put that in. That is 0.22. So the probability there is 0.22. So for A, write down the probability that x is less than 84. Well, that's already in. That's 0.22. Part B, we want the probability that x is between 84 and 90. Well, let's shade that in. Well, that's that region there. Remember that a normally distributed curve is perfectly symmetrical. 50% on the left of the mean, 50% of the right of the mean. So that shaded area is equal to 0.5 minus 0.22, which is equal to 0.28. Part C, we want the probability that x is between 96 and 84. Well, look at the numbers. 84 is 6 below the mean, 96 is 6 above the mean. So we want this combined area. Well, we already know that this is 0.28. And because it's symmetrical, this must also be 0.28. So the probability is 0.28 plus 0.28, which is 0.56. Question 6 is a normal distribution question. We're given a table. First thing we've got to work out is Q. Well, we know that the probabilities always add up to 1, so Q is equal to 1 minus 3 over 10 plus 1 over 10 plus 3 over 20 plus a quarter, which when you work it out comes to 0.2. Part B, find the expected value of x. Well, the expected value of x is we sum the value of x times its probability. So we get the expected value is equal to 0 times 3/10 plus 0.2 times 1 plus 2 times 1/10 plus 3 times 3/20 plus 4 times 1/4. So when you work it out, the expected value is equal to 1.85. Question 7. Let the random variable x be normally distributed with a mean of 16 as shown in the diagram. The shaded region between 16 and 20 represents 35%. Part A, find the probability that x is greater than 20. So we want this shaded region. Well, that is equal to 50%. That is the region that I'm now shading here, which is 50%, plus 35%, which is equal to 85%, which is equal to a probability of 0.85. The faces of a fair six-sided dice are numbered 2, 4, 4, 4, 6, 6. Let x be the discrete random variable that models the sum score obtained when two such dice are rolled. Complete the probability table for x. In order to find out the probabilities, the easiest way to do it is to draw a sample space. Having drawn the probability space, we can now find the probabilities. So the possible scores are 4, 6, 8, 10, and 12, and the probabilities are 1 out of 36, 6 out of 36, 13 out of 36, 12 out of 36, and 4 out of 36. So that's the probability distribution table filled in. Now we can work out the expected value. Remember that the expected value of x is the sum of the probability that x equals x times x. So we've got 4 times 1 over 36 plus 6 times 6 over 36 plus 13 over 36 times 8 plus 10 times 12 over 36 plus 12 times 4 over 36, which when you work it out comes to 26 over 3.